Okay, so today we are starting our 2.2b estimating and solving exponential equations. Okay, we're going to be estimating and doing log with calculator. Okay, so to get started, we're going to talk about solving equations. So in the past, when we had linear and quadratic equations, we were using elementary operations such as addition, subtraction, multiplication. I wrote subtraction twice. It should be division, addition, subtraction, and then this should be division, right? However, we can't use them to solve exponential equations. It's not going to work. Okay. They can be part of the process, but they're not going to give us our answer on solving exponential equations. Okay. So solving exponential equations by estimating is where we're going to start. So to solve by estimation, you will need to find two values of x, the power, that will create a range for the value. So something that it falls in to kind of give you an idea of where the answer lies. Okay. Notice here it says note in order. Uh, to estimate, you have to make sure that exponential is by itself. So repeating, we're going to solve by estimation, and you will need to find two values of x that will create a range for the value. Okay. So let's start here with problem number 6 from your assignment on your practice on 2.2a. So we have 2 to the x equals 9. Well, 2 to the x equals 9, we don't know the inverse operations right now to solve that. Okay. So when we're estimating, we're going to estimate by letting values be x. So if we let x be certain values, so if we let x equal 0, x equal 1, x equal 2, x equal 3, x equal 4, what does that look like? Okay. So x equals 0 means that we have 2 to the 0 power, right? And therefore our output, anything to the 0 power, the output's going to be 1. We have 2 to the 1 power. Anything to the 1 power is itself. We have 2 to the second power, 2 squared, which is 4. We have 2 to the third power, so 2 times 2 times 2 times 2 times 2 is going to give us 8. We have 2 to the fourth power, okay? So that's 2 times 2 times 2 times 2, which gives us 16. Our value that we're looking for is 9. So looking at here, letting x equal what gives us a range of values. So if you look, give us a range that 9 will fall in. So 9 falls between 8 and 16, right? So this lets us know that our approximate answer is x is between, and we're going to say between 3 and 4, okay? But we're going to note that it's closer to 3. Okay. And how do we know it's closer to 3? Well, we know it's closer to 3 because if we look right here, 9 is closer to 8 than 16. Okay. All right. So I'm going to pause and let you try this with the partner. Okay. Let's see how you and your partner did. So we have 3 to the x, and we're going to let x be, there's no point of starting with 0. And so if we let x equal 1, so if we let x equal 1, x equal 2, x equals 3, x equal 4, and x equal 5. Right? So we have 3 to the 1 is going to give us, the output is 3. 3 to the 2, the output is 9. 3 to the 3, the output is 27. Do I need to keep going? And the answer is no. I do not need to keep going because I already see a range where my value is possible, right? So between 9 and 27, that's where 26 lies. So my x value is somewhere between 2 and 3. 2 and 3. But in this case, it's closer to what? It's going to be closer to 3. And that's because 26 is closer to 27 than 9. Hopefully you did well. All right, let's try another one. So this one, we're going to kind of talk about it. In our thing, it said that number one is that your exponential factor or term has to be by itself. So 2 to the x needs to be by itself before I do anything. Is 2 to the x by itself? Exactly. No, it's not. So since it's not by itself, before we do anything, we're going to subtract 1. So I subtract 1, and I'm left with 2 to the x equals 29. Okay, so that's what we're looking for. All right, so we can just go ahead and say we're going to let x equal 2, right? We can let x equal 3. We can let x equal 4. We can let x equal 5. So now when x equals, and if we need to, we can let it be 6. X equals 2, again, that's our 2 squared. That's going to give us 4. 2 to the third is going to give us 8. 2 to the fourth is going to give us 16. 2 to the 5 is going to give us 32. And I can stop here because 29, there's a range where 29 falls. 29 falls between 16 and 32. So therefore, my x value is between what? 4 and 5. So we know that x is between 4 and 5, and it's going to be closer to 5 than 4 because 29 is closer to 32. Okay, so that's approximating. So giving me a window of what my x could be in order for this to be true. Okay, um, that's approximating. All right. So what is the inverse operation for exponentiating? Well, I'm glad you asked. It's called taking a logarithm. Okay, or log for short. So you're taking a logarithm. Okay, and for taking a logarithm, this is our example. So we're going to go back to our example that we had. We had 2 to the x equals 9. Okay. If I want to take the logarithm of both sides, log, L-O-G, I'm going to have it to the same base as my exponent. So my exponent is base is 2, so the base of my log also has to be 2. Okay. An exponential log property says that if I have the log and the exponent of the same base, they're going to cancel each other out. But algebra says what I do to one side, I have to do to the other. So I also have to take log base 2 of 9 so that I'm staying equal and balanced. So what I did to one side, I do to the other. Okay, so this undoes the exponential. It's going to eliminate, and I'm just going to be left with x. So this is my exact answer. My exact answer is x equals log base 2, 9. Okay, and so then when we didn't do a graphical analysis, but when we did our table analysis, the value of 2x of 9, we can graph and we can look and we'll not graph and look, but we can substitute and plug in and look and see that it's going to be 3.17 when we're putting it into the calculator. So we're going to put this into the calculator to get our value. Okay. And our table analysis told us that our answer fell between it said it fell between 3 and 4, but it's going to be closer to 3 because 9 is closer to 8 than 16. So when we actually do it and we type it in the calculator, we end up with approximately 3.17. Okay. And we're going to talk about how to get that in the calculator. All right. So solving exponential equation. Here are our steps that we're going to follow. Step 1 is that we want to make sure. So step 1, we want to make sure that the exponential term and factor is by itself. Okay, to do that, we're gonna use addition, subtraction, multiplication, divide if need be. Step 2 is we're gonna take the log of the same base of the exponential to both sides. Okay. Step 3 is the log will undo the exponential and set the power free. Okay, that's our x is gonna be set free. Step 4, we're gonna input the log into the calculator. To input the log into your calculator, you're going to press alpha window and select the fifth option that says, or the menu that says log base parenthesis. Okay. Then we're going to press enter and approximate to 3 decimal places. All right. Now, your calculator, you can do this skill right here. However, if you have an older calculator like I'm about to model with, it's not going to necessarily work. So this is another way. Once you're in this form, it's called change of base. You're going to take the log of your index. Is this what it's called? I had a brain fart. But the log of your value here divided by the log of your base. And that's going to still give you the approximate value. So if for some reason you're not able to do part 4 with your TI-84, where you're pressing alpha window and select the 5th option from the menu, log base, then you have the second option of changing the base and go from there. So for example, if I have log base 57 in the calculator, I'm going to put log 7 in the numerator, 5 in the denominator. Or I can do natural log as well, and I'm still going to get the approximate value of what the log is. Okay? All right, let's do some more. So here, sorry that it's so tiny, but it's 3 to the x equals 27. So 3 to the x equals 27. 26. I don't know why I said 27. So I'm going to take the log of both sides. So I'm going to take log, and it's going to be the log of the same base of our exponent, of our exponential, and that is 3. So we're going to have log is 3. What I do to one side, I'm going to do to the, I'm going to squeeze it in there, log base 3. What this does is that it's going to set our power free, and now we have x equals log base 3, 26. This is our exact value. Now we're going to go to the calculator to find our approximate value, okay? Now in my calculator that I have to show you with these notes, right? I'm going to write it in log base form. So this is my exact answer. So this is my log, but I'm going to write it as calculator log 26 divided by log of, okay? So let me open the calculator. I have the old school handy dandy calculator here, and it doesn't have that option where I get the fancy tool. So I stick to what I know. So my numerator is log 26. My denominator, so divided by log 3. I kind of find this to be a little faster and easier personally. And I'm going to hit enter. And I get that my value here is 2 and 900 and about 66 thousandths. If you're not good at rounding, you can always click mode and take it from float. And we're going to put it on 3 decimal places. I don't know why there we go. 3 decimal places. So now I'm going to hit second quit to get back to my calculator page. And when I hit enter again, it'll round it. And it'll be doing it for the rest of the time now. So approximately 2 and 966,000 is what we have to do. Okay. And like this problem, we said that our value was between 2 and 3. So in our previous example, we said that our possible x is between 2 and 3, but closer to 3. And were we correct? We were correct. Okay. All right. So let's look at example 5. I'm going to pause for a moment and give you a chance to do example 5 with the partner. All right, let's see how you and your partner did. So again, the first thing is that the term with the exponential has to be by itself. Is this by itself? Good. No, it's not. So we're going to subtract 1 like we did already. So we have 2 to the x equals 29. Okay. So with that, now we're going to take the log. So we're going to take the log. I'm going to switch colors for you. Okay. We're going to take the log, and our log has to be the same base as our exponential. So our log is going to be 2, and what I do to one side, I'm going to do to the other. This is going to cancel out, and I'm going to left x equals log base 2 of 29. Okay. This, again, is my exact answer. Okay. I'm going to use the calculator to approximate it, and again, I'm going to use the change base formula. So my value, log 29 over my base, log 2, and I'm going to plug that into the calculator. and get my approximate value. Remember, my calculator is already set to round for me. So I'm going to go log 29 divided by log 2. Enter, and I get 4 and 858 thousandths. 4, approximately 4 and 858. And that's about on brand. Not on brand. That's about right, because we said that our values between 4 and 5 are possible value, but closer to 5. Okay. All right. Let's try a harder one. All right, so this is a multi-step example, and it's a multi-step example instead of just a two-step example, because there's something with our exponent. And so we're going to have to also deal with that, okay? Goal number one is that you have to isolate your term with your exponential. So I need to get this by itself. In order to get it by itself, I have to add 2 to both sides, right? So when I add 2 to both sides, I'm left with 3 to the x plus 1 equals 102. Okay, next I need to set the power free, right? So I need to set the power free. In order to set the power free, that's when we take the log of both sides. So I'm going to take the log with the same base of our exponential. So log base 3, that's going to set our power free. And what we do to one side, we're going to do to the other. Equals log base 3, 102. Okay. And now this is why it's multi-step, because my x is not by itself. So before I do anything, I need to get x by itself. So in order to get x by itself, I'm going to have to subtract 1. Okay. So that means we get x equals log base 3, 102 minus 1. This is my exact answer. This is my exact answer. Okay, that's my exact answer. Now, we're going to use the calculator to find our approximate. And again, for me, I'm going to have to use change base because I don't have a fancy calculator that lets me put in log base 3. Okay, so I'm still going to do this first. I'm going to do my division just like that. But after I do the division, I also need to subtract 1. So again, it's going to be the log of my value, which is 102, divided by log of my base, which is 3. But now minus 1. I'm going to get my approximate value from the calculator. Right click my thing. I'm going to type in log 102 divided by log 3. Notice I'm closing all my parentheses of my log, minus 1. And I get 3 and 210. That's my approximate value. Okay, so on your assignment today, you're going to be, you're going to need to make sure you write the exact and your approximate, doing exactly what we did. And hopefully you felt like this was easy. And if you have any questions, please let me know. Your assignment is attached to your notes. And that we will be having a quiz over this and writing equations, math sentences, and their inverses on Friday. Thank you.